Okay, Bismillahirrahmanirrahim. My name is Wahidullah and I am chemistry lecturer here at Kurtuba School and Colleges. Welcome back, dear student. It's our second lecture and the content of our second lecture is reversible reactions and dynamic equilibrium. We will be explaining what is chemical equilibrium as well and how to represent it graphically. So dear student, as we discussed in our previous lecture, that reversible reaction is actually a type of a chemical reactions in which reactant react with each other and they form product. While these product react or recombine with each other and form the reactant back. As I told you that this reaction does not go to completion. Let me give you an example. Okay, this is an example in which hydrogen gas along with iodine react and they gives us hydrogen iodide. As I told you that these reactions will be represented by a double arrow. So here what is actually happening, these two reactants react with each other and they form product, while this product is decomposed back into the reactant. Actually this reaction is composed of two reactions. We say that one of the reaction is a forward reactions while the second reaction is a reverse reaction. So forward reaction is that type of a part of a reversible reactions in which reactant are converted into product, while reverse reaction is that part of a reversible reactions in which the product are converted back into the reactant. Let me elaborate it further. Like you can see here in this case, H2 plus I2, they give us 2H I. So here the forward reaction was like the reactant here in both of them was H2, hydrogen and iodine, and they were giving us 2 moles of hydrogen iodide. So the backward reaction or the reverse reaction of that reversible reaction was that 2 hydrogen iodide, 2 moles of hydrogen iodides were coming back and were forming H2 plus I2. As you people can see here, what was happening, like H2 were combining with the I2 and they were forming 2 moles of hydrogen iodide, and similarly these 2 moles of hydrogen iodide were reacting back or were decomposing and were forming 1 mole of hydrogen gas and also iodine gas or iodide. Similarly, you can see here the forward reaction of that reversible reaction is that hydrogen react with I2 and they forms 2HI, hydrogen iodide, and the reversible part of that reaction was that 2 moles of hydrogen iodide react and they gives us H2 along with I2. So dear students, now it's time to explain what is dynamic equilibrium. Well, dynamic equilibrium is a condition, or it's a state at which the rate or speed of two processes dynamic equilibrium is a condition or a state at which the rate or speed of two processes will be same. But remember, these two processes or these two reactions will be in opposite direction. How? Like let me give you a common life example. For example, let's suppose we are having a bathtub. This is a bathtub. Okay, and let's suppose we are having a small hole right over here. So what will be happening, like in the very beginning, when we start adding some amount of water, so here at that step, this is considered, this is first process. This is first process, so amount of the water which is entering into the tub is not equal to the amount of the water which is coming out of the tub. But after some time what will be happening, like when we are adding extra amount of water, so here in that case some amount of water will escape out from that bathtub. So here the amount of water coming into the tub is equal to the amount of the water coming out of that bathtub. So at that, this is the condition which we say that it's we have achieved, or the system have achieved, dynamic equilibrium. Similarly, chemical equilibrium is actually one of the type of dynamic equilibrium, at which here at the state of a chemical equilibrium, rate of forward reaction equals to rate of reverse reaction. Dear students, as I wrote it here, that chemical equilibrium is a type of dynamic equilibrium. Similarly, as dynamic equilibrium is also a condition or a state, so chemical equilibrium is also a state or a condition at which the rate of forward reaction is equal to the rate of reverse reaction in a chemical system or in a chemical reactions. When the rate of these two reactions becomes equal to each other, so that state or that condition is called chemical equilibrium. At chemical equilibrium, we will be having same amount of concentration, same concentration. By same concentration, we mean that, let's focus here on this example, like at equilibrium, what will be happening? Equal amount of hydrogen gas and I2 gas will be reacting with each other, and they will be forming two hydrogen iodide, 2 moles of hydrogen iodide. At the same instant, 2 moles of hydrogen iodide will be reacting back, and they will be forming the same amount of H2 and I2 gases. So here, there will be no increase in the net concentration of both reactant and both product. The concentration of reactant and product will remain the same. Like there will be no change in their product. Dear students, now it's time to explain it graphically. We know that in a graph we take two axes. One is called x-axis, while the second one is called y-axis. Here on y-axis we will take rate of a reaction. On x-axis we will take time. So actually, in the very beginning of the reaction, as you people can see that we will be having no product, which means that here in this case, the rate of forward reaction will be maximum. So consider this is a graph. So here, this dot actually tells you that the rate of a reaction, and that dot is denoting tells you about the rate of a forward reaction. So at the very beginning, the rate of a forward reaction will be maximum, while at that instant this dot tells you about the rate of reverse reaction. Here at the very beginning, the rate or speed of a reverse reaction will be minimum. Now, as the time goes on, so what will be happening, that the rate of a forward reaction will go slowly down and the rate of a reverse reaction will move up. So, a condition or a state will come where the rate of a forward reaction becomes equal to the rate of reverse reaction, and that state or that condition is called chemical equilibrium. As you people can see that after some time, both the lines touches each other and they form a straight line. So here at that instant, rate of a reverse reaction equals to the rate of the forward reaction. At that condition or that state is called chemical equilibrium. Okay, thank you so much.